Hey there, Keys Precalculus. I'm going to go over 3 examples from section 7.3 today. In class, we learned how to perform elementary row operations on a system of linear equations to turn that system into what we call a row echelon form. And that means we take a system like you see on this screen and turn it into a stair-step system where the first row, the top row would have all the variables if needed, or then the second row would have 2 of the variables, and the last row would have 1 variable in it, and all of the leading coefficients would be 1. If you had 4 variables, then you would have 4 lines, and it would be a 4, 3, 2, 1 type of system. Or even if it's not, like if one of the variables was missing, you would still, on the first row, start with the x, then the second row the y, then the third row the z, and so forth. And all of the leading coefficients, or the first coefficients, I should say, would be 1 in the system. And when we do this example, you will see at the end what that looks like. Or, if you wanted to see what it looked like now, you could go to page 473 in your book and look at the example in the middle of the page of a system that is in row echelon form. So the way that you put a system of equations into that form is you do a process called Gaussian elimination, which is just basic elementary row operations that you perform onto the system of equations to turn it into a new form. And those operations are, you can interchange any of the rows or equations, if you want to, either way you want to call it. I'm going to say row, but it means equation. You can multiply any row by a non-zero constant. Like if you needed to get rid of the 3 in the middle row, you could multiply everything by a third, and you would get rid of that 3, and you'd make the leading coefficient 1. We're not going to do that, but you could. Or you could add or subtract a multiple of any one row to any other row to create a new row in its place. We did this in class, but I'm going to do a few more examples here with you just so you can practice. If you were not absent, then at this point I would like for you to pause the video and work page 44, problem number 21 on your own. And then come back and we will work it together. Just keep in mind that you may not do things in the same order that I do them, or you may not do exactly the same elementary row operations. That's okay. There is always more than one way to approach these problems. And as long as you do your arithmetic correctly, then you will get the same answer that I get. So understand that what you work may not be the same thing that I work when you come back and do it with me. But if we get the same answer, it's okay. We just have approached it a little bit differently. If you were absent, then just keep the video on and work with me through this example. Okay, first thing I'm going to do is I'm going to label this row 1, row 2, and row 3. You do not need to do this on your homework unless you want to. I'm just doing it for clarity's sake today. Okay, so what I'd like to do, instead of trying to make my leading coefficients 1 to begin with, because if I did try to do that, then I would be dealing with fractions, and I don't want to do that the whole time. So instead of that, I'm going to try to eliminate term in the second row and the first and second term in the third row to begin with. Okay, so I'm going to leave my first row alone. I'm just going to put a check there because I'm not doing anything this time. But this time I am going to try to get rid of the first term in the second row. Now, in order to do that, I look at all of my rows and say, what would be the easiest way to do that? Well, I've got a 3x in my first row and a 3x in my second row. So I think it would be easiest to replace the second row with a row 1 minus a row 2. Because when I take the first row and I subtract the second row from it, I'm going to get a new row without an x term in the second one. Sorry about all that noise. I think it's my connection to my pad, my writing pad here that's making that. So the first row, I'm going to rewrite 3x plus 3y plus 5z. I'm not doing anything to it, so I'm just going to rewrite it completely and leave it for now. Then my second row, what I'm going to do here is I'm going to take my first row, row 1, and I'm going to subtract row 2. When you do this, it's a really good idea to write down what you're doing so that if you make a mistake, you can go back and see perhaps where your mistake was instead of trying to remember what you did. So first term, 3x in the first row minus 3x in the second row gives me 0x in my new rewritten second row. But I don't need to write it. It doesn't need to be there. And then I can say 3y minus 5y gives me negative 2y in my new second row. And then from the first row, 5z minus from the second row, 9z gives me negative 4z in my second row. And then don't forget to do the last term, what it equals. 1 minus 0 equals 1. So now I have a new second row. And I got it by taking the first row and subtracting the second row from it. Now the next step is to try to eliminate the first variable from the third row. And so as I look at that, think, okay, what is the easiest way to do that? Well, I need to, I can look at the second row and the third row and see if I can deal with those. I can't easily just say 3x minus 5x to get 0. But I could multiply the second row by a number, by 5, and I could multiply the third row by 3, and then subtract the 2 rows and get a new answer. Or I could do the same thing with the first row and the third row. Because I've got smaller numbers in the first row, relatively smaller numbers, I'm going to go ahead and do that. I'm going to deal with the first row and the third row. But it doesn't matter. You can do it with the black second row, the original second row, and the original third row if you'd like, because we're still rewriting the new set. But I'm going to choose to use the first row and the third row. The black first row and the black third row in my original set. So I'm going to take 5 times row 1, and I'm going to subtract 3 times row 3 from it to get a new row 3. This is just like the regular elimination method if you had 2 linear equations in a system. So this is nothing different. I'm going to do a lot of this in my head and write the answer down. You can use scrap paper if you want. You can do it in your head. But the first thing I'm going to do is I'm going to say 5 times this black 3x in the first row to give me 15x minus 3 times this black 5x in the third row to give me negative 15x. And 15x minus 15x is 0x. I'm not going to represent that with anything. I'm just going to leave it blank. Now I'm going to take 5 and multiply it by the black 3y in the first row. So 5 times 3y is 15y. And then 3 times 9y gives me 27y. So 15y minus 27y is negative 12y. Okay, and now I'm going to take my 5 and I'm going to multiply it by the original 5z, the black 5z in the first row, to get 25z. And then I'm going to take 3 times row 3, the 17z, the black 17z, to get 51z. So 25z minus 51z gives me negative 26z. And then now I'm going to take 5 times this 1 and 3 times 0. 5 times 1 is 5, 3 times 0 is 0, and 5 minus 0 is 5. So I'm going to write that down here. So that's how I got my new set, my new system of equations. It's equivalent to this black set. The pink set is equivalent to the black set, but it looks different. Okay? So you may have done something a little different in your first step, so just bear with me. You probably didn't do anything wrong. You just did something different. And that's okay. Now we're going to move on to the next steps. I have my 3x. I start with my 3x in my first row. I have a negative 2y in the second row. I don't really want to do anything to those, so I'm just going to check them off and rewrite them as they are. But what I want to do now is I want to get rid of this negative 12y in my third row. So how am I going to do that? Well, I could multiply the first row by 4, because 3y times 4 would give me 12y, and then add the first row to the third row. And that would eliminate this middle variable. But you know what it would also do? It would add back in my x variable, because 3x times 4 would be 12x, and 12x plus nothing is 12x. So I don't want to do that. I don't want to deal with my first and second row, or excuse me, my first row and my third row, because if I do that, I would introduce my x back in. Because I can't multiply by 0. I have to multiply by a non-zero constant. So I'm going to have to deal with my second row and my third row. And the best way to do that is to take my first row, because I can, excuse me, not my first row, my second row. I can take my second row, I can take this 2 and turn it into a 12, or a negative 2 and turn it into a positive 12. And I can do that by multiplying my row. I'm gonna write what I'm gonna do beside my third row, because I'm gonna replace my third row. But I'm gonna take row 2, and I'm gonna multiply it by negative 6, because negative 6 times negative 2 gives me a positive 12, is what I want. Negative 6 times row 2, add it to row 3. That's going to give me my new row 3. So over here, I'm going to rewrite row 1, because I haven't done anything with it. 3x plus 3y plus 5z equals 1. It's the original that I started with. Then my new second row is 2y, negative 2y, minus 4z equals 1. And now I'm going to write a new third row by combining negative 6 times my second row plus my row 3. So negative 6, so I'm going to come up here to my pink and work with my pink now, not my black anymore. I'm done with that. I'm working just with my pink. So negative 6 times negative 2 gives me positive 12y, and positive 12y plus negative 12y is 0. So I don't need to represent that. I don't need to put anything there. But then I've got to finish it out. So negative 6 times negative 4 is positive 24. And positive 24 plus z plus negative 26z gives me a negative 2z for my new third row. And then negative 6 times my 1 in the pink second row plus 5 in my pink third row, negative 6 plus 5 equals negative 1. So I have a new system. It's the same system, but I've written it in a new way. And now I have this stair-step pattern I'm looking for in row echelon. But it's not finished because my leading coefficients are not 1. Now I have to be honest. When I am solving these, I don't always go to row echelon. I will often leave it right here in this form, because that way I'm not having to deal with a bunch of fractions. But because we are learning how to put it in true row echelon form, I want all of my leading coefficients to be 1. And so I'm going to demonstrate that and do that here with you. You need to follow instructions if that's what it tells you to do, but to be honest, I think it's just as easy to solve it in this form, now that it's stair-step, than it would be to solve it in just true row echelon form. So to make my leading coefficients 1, I would have to multiply row 1 by 1/3. And I would have to multiply row 2 by 1/2. And I would have to multiply, by negative 1/2, sorry, because I want it to be a positive 1. And I would also have to multiply row 3 by negative 1/2 in order to get my system into true row echelon form. So when I do that, 1/3 times every element in the first row would give me x plus y plus 5/3 z equals 1/3. And then when I multiply my second row by negative 1/2, I get y plus 2z equals negative 1/2. And then when I multiply my third row by negative 1/2, I'm going to get a z equals positive 1/2. So now that I know what z is, I can do back substitution and figure out what y is and what x is. So I'm going to have an ordered triple here, and I know that in my ordered triple, my z is 1/2. I do not know my y or my x yet, but I'm going to figure it out. And I'm going to figure it out by taking this 1/2 and replacing the z in the second equation with it. So over here, I'm going to say y plus 2, hold on, I'm trying to change my color here, times 1/2 equals negative 1/2. And when I solve that, I get y plus 2 times 1/2 is 1 equals negative 1/2. And if I subtract 1/2 from both sides, I get y equals negative 3/2. So I'm going to put negative 3/2 in my y space in my triple pair. Not my ordered pair, my ordered triple, sorry. Sorry for saying it that way. And then now I'm going to take, now that I know what my x is and what my y is, excuse me, I know what my z is and I know what my y is, I'm going to replace my y right here with the 3/2, and I'm going to replace my, or negative 3/2, sorry, and I'm going to replace my z in this one with a 1/2. So I'm going to rewrite my second equation, excuse me, I'm going to rewrite my first equation as x plus, and instead of y, I'm going to replace y with a negative 3/2 plus 5/3 times, instead of z, I'm going to put a 1/2 in there, equals 1/3. So when I simplify this, I get x minus 3/2 plus 5/3 times 1/2 is 5/6 equals 1/3. So then when I combine like terms, I get x, and then negative 3/2 plus 5/6 is the same thing as saying negative, you multiply it by 3, so I get negative 9/6 plus 5/6, and negative 9/6 plus 5/6 is negative 4/6 equals 1/3. And then when I add the 4/6, which actually reduces to 2/3, so if I add 2/3 to both sides, then I end up getting x equals 1. So my first element in my ordered triple is a 1. This is the correct answer. You can go back and check it with the original black. If I substitute a 1 in for the x, negative 3/2 in for a y, and a 1/2 in for my z, and all three equations, I should get a 1, a 0, and a 0. And that's how you check to see if your ordered triple works. But this is the correct answer. You may have gotten your system equation into row echelon form in a different order than I did. But when you do put it in row echelon form, in true row echelon form, you should have come up with this blue system right here that you could just use back substitution to get your ordered triple as your answer. Now we looked at examples 3 and 4 together in class. I'm not going to go over example 3 with you again, but I do want to go over example 4 with you one more time. So we can look at this example and we see that my row 1 is in decent form. I don't need to change it yet. My row 2 is also in decent form. I don't have an x element. I have my leading coefficient of my y's being 1. I don't need to change anything in my second row right now. But my third row does need to change. I need to eliminate the x and the y. So the easiest thing to do first is to eliminate the x, and I have to do that with row 1. I can't do it with row 2 because there's no x in row 2 to eliminate an x in row 3. So this is very simple. All I have to do is take row 1 and I subtract. No, I don't even have to subtract. I can just add because the signs are different. I can add row 3 to it to get a new row 3. So the first thing I'm going to do is rewrite my row 1, x plus y minus 3z equals negative 1. And then my second row I'm going to rewrite, because I don't have to change it, y minus z equals 0. Now my third row I'm going to get by adding, a new third row I'm going to get by adding the black first row and the black third row. So x minus x, or x plus negative x, is nothing. I don't have to write that. Y plus a 2y is going to give me a 3y. And then my original negative 3z plus nothing gives me negative 3z. And then negative 1 in my first black row plus positive 1 in my third black row gives me a 0. So here is my new looking system of equations. It is equivalent to the pink system of equations is equivalent to the black system, but it looks a little different because I performed some row operations on it. Now I've got to do something else with my third row. I don't want my y element in there. I want it to become 0, so I need to do something with it. If I use my first row to do that, I would introduce the x back in there. So I'm not going to use my first row. I'm going to use my second row and my third row to get a new third row. First row is still okay. Second row is still okay. Third row needs to change. So how am I going to do that? Well, I'm going to have to multiply the second row by 3, and I'm going to have to subtract the third row from it to make this y element 0. So I'm going to rewrite this in green now. My first row again stays the same, x plus y minus 3z equals negative 1. My second row is staying the same, y minus z equals 0, but my third row is going to change. I'm going to take this pink second row, multiply it by 3, so 3y minus the pink third row minus 3y gives me 0, so I don't need to put a 0 in that place. I can just leave it blank. But I need to finish the rest of it. 3 times negative z gives me, in my pink second row, gives me negative 3z minus a negative 3z also gives me a 0. I do need to put a 0 there because I've got to represent that. I can put 0z if I want, but I don't need the z. And then the last one is 0, 3 times 0 minus 0 gives me 0. So I have this true statement, 0 equals 0 in my third row. And it's true always. So that means, and I have no z, because a z really, I don't need to write it because it's multiplied by 0, so it's just 0. So now I have this true statement. I have two equations in my system, and my third equation is just this true statement. That means there are infinite solutions to this system. But it's not just any old number. I have to represent those infinite solutions somehow. Okay? So I do need to give it an order triple, and this is how we're going to do it, and this is what I wanted to go over with you. Z can be anything right now. We don't know what it is. But if I look at my second row here, I can rewrite z in terms of y, or y in terms of z. I can just move my z to the other side, and I can rewrite this as y is equal to z. That means that no matter what z is, y is going to be the same thing. So I can rewrite my first equation now in terms of x and one other variable. Well, I'm going to replace my y with the z that's equivalent to it in here. So I'm going to get x plus, and instead of y, I'm going to replace it with the z because I can. Because z is equivalent to y, right? Minus 3z equals negative 1. So that can be simplified as x minus 2z equals negative 1, which means my x is equal to 2z minus 1. Look at it again. Pause the video if you need to. I just rewrote my top equation, my green top equation, in terms of x and z. I substituted z for the y because they were equivalent, and then I simplified, and then I moved everything to one side. So, but I also wrote it down wrong. I wrote a z in place of, I wrote an x in place of a z. That should have been a z right there. Sorry about that. Let me fix that. This should be 2z minus 1. So my x is 2z minus 1, and my y equals my z. So how do I write that as an ordered triple? Well, what we're going to do is we're going to replace my z with any number. I can choose any number I want with z. So what I'm going to do is I'm going to let my z equal a for any number. So if my z is equal to any number, then my ordered triple will be, my x element will be the 2 times any number I choose for z minus 1. My y is equal to z, so it will be a, and my z will be a. So that is my ordered triple right here. And I can test that with any number I want. Let's let z be 0. If z was 0, so over here, let me use another color. I'll use pink. So if I let z, instead of just being any number, I'm going to choose 0, then my ordered triple will be, or I can say let z equal 0 or let my any number equal 0. It may be a be 0. It doesn't matter. 0. So if I come over here to my blue box, 0 times 2 is 0, minus 1 is negative 1, and then 0 and 0. Because if z is 0, then that means y is 0. That means that I'm going to put 0 in place of this z, or this a here. And 2 times 0 is 0, minus 1 is negative 1. So when I let z be 0, or a be 0, then this is my order triple. Or what if I let my a or 0, it doesn't matter what, or excuse me, a or z, whatever you call it, let it be 1. Well, then what would my new order triple be? Well, my z would be 1, my y would be 1, and then I would come over here and I would replace the a with the 1. 2 times 1 is 1, and 2 minus 1 is 1. So I would have a order triple of 1, 1, 1. Well, what if I let it be a or z, whatever you want to call it, be equal to negative 1? Well, I know that my y would be negative 1, my z would be negative 1, but what would my x be? Well, negative 1 times 2 is negative 2, and negative 2 plus negative 1 is negative 3, and so on. So there are infinite solutions. I can choose anything I want for z, and then find out what y and x would be by doing that. But I can't just make up an order triple. I can't just say 1, 2, 3 works, because it doesn't work. There are infinite order triples that work, but they have to be in the form of 2a minus 1, a and a. Or you could write it as 2z minus 1, z and z. Or however you want to put it. But it's easier just to put a in for any number. Okay, do y'all see how that works? Okay, the last example I'm going to do is example 5. It's a non-square system, and we did not look at this in class. This works very similarly to the last problem we just did, though. Non-square systems are systems where I have, like in this example, 3 elements, but I've only got 2 rows. I have 3 variables, but just 2 rows. Or I might have 4 variables and 3 rows. Okay, so how am I going to solve a system that is not square? Well, the first thing we're going to do is we're going to put it in row echelon form, even though it's not square. So I'm going to study it. My first row, it seems okay. I don't need to do anything with it. I've got my x. I start with my x, and its coefficient is 1. My second row, though, I need to get rid of that x element. So the way I'm going to do that is I'm going to take the first row, multiply it by 2, so 2 times row 1, and I'm going to subtract row 2 from it. And when I do that, I'm going to get rid of the x element in my second row. So my first row, I'm just going to rewrite as x minus 2y plus z equals 2. And my second row, my new second row, I'm going to take my first black row, multiply by 2, and subtract the second black row from it. So 2 times x is 2x, minus 2x is nothing, and I don't need to write it. And then 2 times negative 2y gives me negative 4y, minus a negative y is going to give me negative 3y as my first element in my new second row. And then 2 times z in my first row minus a negative z gives me 3z. 2z minus a negative 1z is 3z. And then 2 times 2 is 4, minus 1 is 3. All right, so now I need my first row is still good. My second row, though, I need to make it with a leading coefficient of 1. And the way I'm going to do that is multiply my second row by negative 1/3. Okay, row 2 times negative 1/3. That will give me a leading coefficient of 1 in my second row. So my first row, I'm just going to rewrite. It's still good. X minus 2y plus z equals 2. And then 1/3 times negative 3y gives me positive 1y. Or negative 1/3 times negative 3y gives me positive 1y. Sorry. Negative 1/3 times 3z is going to give me a negative 1z. And then negative 1/3 times 3 gives me a negative 1. And so now I have a system of equations in row echelon form that is not a square system. So what do I do next? Well, it's easiest for me to look at this last row here because I've only got 2 variables, and I'm going to rewrite y in terms of z. So y is equal to z minus 1. This is just like the substitution property we used in 7.1 to solve systems of equations. So I'm going to rewrite my y now in terms of z. So y is z minus 1. And I can now substitute it in place of that y. So I'm going to come down here and rewrite my system with terms of just x and z. So my first line becomes x minus 2. Again, this is a substitution property. And instead of y, I'm going to write as z minus 1 plus z equals 2. And now I'm going to simplify it. First, I'm going to distribute my negative 2. So I'm going to get x minus 2z plus 2 plus z equals 2. Okay, then I'm going to collect like terms. So I get x. Negative 2z plus z is negative z plus 2 equals 2. And then I'm going to subtract 2 from both sides, and I get x minus z equals 0. So x equals z. So I have now rewritten my x in terms of z. So I have a y as being z minus 1, and I have an x as being z. So my ordered triple, instead of being an x, y, z, I've got to put numbers in place of that. I'm going to have more than one solution. It's going to be an infinite amount of solutions, but what form do they need to be in? So what I'm going to do, just like we did before, is I'm going to let my z equal a for any number, right? So in my ordered triple, my z is going to be a. And then my y is going to be in terms of that. So it's whatever number I choose for z minus 1, because y is z minus 1. And my x, because my x has ended up being z, that is also going to be an a. So my ordered triple is a minus 1, a. And I can do this for, I can choose some a's just to test it. So let's let my a equal 0. So if a is 0, my ordered triple would be 0. 0 minus 1, which would be negative 1, 0. Will that work if I put in a 0, negative 1, and a 0 in my system? Well, let's see, a 0 here, and then negative 1 times negative 2 is positive 2, plus 0, yes, that equals 2, and then that becomes 0, and that becomes a negative 1, which will become positive 1, 0, and 1 equals 1. So yeah, that works. Okay, I could let my a be something else. I could let my a equal 1. Well, if it equal 1, then that would be 1. 1 minus 1 is 0, and then 1. Does that ordered triple work? Well, yeah, let's see. 1 in place of x, 0 in place of y, and a 1. 1 plus 1 is 2. Or a 2. Well, 1 in place of x makes that 2. That makes that 0. Minus 1. 2 minus 1 is 1. So yes, that works. Okay, try one more. Let's let a be a negative number. Let's let it be negative 1. If that were true, I would have negative 1. Negative 1 minus 1 is negative 2. And negative 1. Well, let's see if that works up here. So if I have negative 1 in place of my x, negative 2 times negative 2 is positive 4, and a negative 1, well, 4 minus 1 minus 1 is 2, so that works. And then here, negative 1 will give me negative 2, and then negative 2 to a negative would be a positive 2, that's 0, and then a negative 1 here, the negative of negative 1 is positive 1, so yes, that works. So you can see that no matter what you put in for a, you can figure out what the other two elements are, and that would be your ordered triple. So your infinite set of ordered triples would be in the order of a minus 1, a in this case. And that is how you solve a non-square system. It's very similar to solving a system with infinite equations. Okay? So that's all we're going to do for this part of the lesson. There's another video for the second half of 7.3 that y'all are required to watch this weekend. We will learn how to do that in class, but I want you to be familiar with it before you come to class on Tuesday. Have a great weekend.